let's be honest, a little dense. Today, and that's the feeling, right? It just feels like Tonic is doing some kind of magic. So if gRPC has ever seemed like a magic trick, think of this explainer as your all-access backstage pass. We're about to pull back the curtain and show you exactly how the trick is done. So if you've ever tried to write a gRPC service, I bet this looks pretty familiar. You get hit with this wall of types that feel almost alien, right? What's the deal with box? Why do we suddenly need pin? And how on earth does this stream actually work? It's a lot, I know. But today, we're going to break it all down. Okay, so this is it. This is the code we're going to tackle. It's a full gRPC server for a streaming chatbot. And yeah, it looks super intimidating, I get it. But I promise you, by the time we're done here, every single line is going to make perfect sense. This is the magic trick we're about to demystify. Together. All right, so let's start with something easy to build up. A little confidence. We're going to look at the most straightforward piece of this whole puzzle, the simple request response, or what's called a unary call. So the first thing you'll probably spot is this @tonic async trait attribute. This little guy is a macro, and it is doing some serious heavy lifting for us, especially when we start talking about Rust's async features. So why our magician? Well, you know, Rust doesn't natively support async FN inside traits. Not without a ton of painful boilerplate code anyway. This macro basically acts like that magician. It just swoops in, handles all that complex, messy setup behind the scenes, and lets you write your async logic without the headache. It just works. Now, this send message function? This is the absolute bread and butter of any RPC system. The client sends one single message, our server does whatever it needs to do, and then it sends back a single ACK to say, yep, got it. It's a simple one-to-one conversation. Super straightforward. Okay, warm-up is officially over. We've handled the easy stuff. Now, it's time for the main event. Server-side streaming. This is where the code gets a lot more interesting, and where that real magic seems to be happening. And here it is. This is the heart of all the confusion. Just look at the difference. On the left, our simple unary call, it just returns a response. Easy enough. But on the right, our streaming call returns that. A pin, of a box, of a dyn stream. What even is that? This is the exact type signature we are about to tear apart and understand. But before we get lost in the weeds of that type signature, let's use a real-world analogy. Think about a Twitch stream. It's basically the same thing. You, as the client, connect once. You make one request that says, hey, I'm here. And then the server, just like your favorite streamer, starts sending a continuous flow of data, video, chat, whatever, back to you. That's the core idea. One request in, many responses out. So in our sample code, we're just faking a stream, right? We're taking a simple vector of messages and we're turning it into an async stream with stream.iter. But here's the crucial part. Notice how each message gets wrapped in a result.ok. Why do we do that? Well, because in a real gRPC stream, any single item coming down the pipe could be your data, or it could be an error. So using result is the perfect way to model. All right, the moment of truth. Let's dive headfirst into that crazy-looking return type. We're going to break it down one piece at a time and see exactly what each keyword is doing for us. Okay, there it is in all its glory. And I know, it looks like a total mess. But don't be intimidated. Every single part of this, pin, box, dyn, it all has a very specific, very logical job to do. Think of this whole thing as a recipe for creating a safe and efficient async stream. So let's build this thing from the inside out, like stacking Legos. At the very core, we have stream. Just think of it as an async iterator. It gives you items over time. But Tonic doesn't know the exact type of stream we're returning at compile time, so we need dyn stream to say, hey, this is some kind of stream. But that creates a new problem. Dyn types don't have a size the compiler knows about. How do we fix that? We put it in a box. A box stores our stream on the heap and gives us a simple pointer, which does have a known size. Problem solved. But wait, there's one more thing. For async code to be safe, Rust needs to know that our stream won't move around in memory while it's in the middle of an operation. And that is the whole job of pin. It literally pins our boxed stream in place, guaranteeing it won't move.
You see, each piece solves a problem created by the last. It's just a logical chain.
You know, a really great way to picture all this is to think of a factory conveyor belt. The stream is the belt itself, moving the items along. The box is the sturdy metal frame that holds the belt up. And pin? Pin is the set of heavy-duty bolts that lock the entire contraption to the factory floor, making absolutely sure it won't wiggle around and drop your precious data halfway through. Okay, so now you got the mechanics. You understand the types. But so what? How does this actually help you write better code? Well, let's talk about some pro-level takeaways and, more importantly, some common pitfalls you'll want to avoid. Here are the big ones, the common tripwires you really want to watch out for. First, and this is a big one, always remember to map your stream items into OK. It's so easy to forget. Second, if you're building a Dyn stream yourself, box.pin is the tool you're looking for. Third, don't forget that the request object isn't just your data payload. It can have really valuable metadata in it, so check it out. And finally, when you're making streams that are truly dynamic, like things are happening in real time, Tokyo's MPC channels are absolutely your best friend. Seriously, just use them. And all of this really points to a bigger idea, a shift in how you think. You know, getting really good with a tool like Tonic isn't just about memorizing syntax. It's about a mental shift, moving from someone who just uses gRPC to someone who actually designs with it. And what does designing with it really mean? It just means you start thinking naturally in async streams. You take full ownership of the API contract, and you know exactly how all these pieces, the box, the pin, the stream, fit together. And that is what gives you total control. And that's really it. The magic trick is over. We've pulled back the curtain, you've seen how it all works, and now that understanding, that power, is in your hands. So I guess there's only one real question left. Now that you know the secret, what are you going to build with it?